So we're going to be learning about accelerating your development with the latest MongoDB innovations. We all like innovations, right? All right. So without further ado, please give a warm welcome to Nishith Atreya, our product manager here at MongoDB, who's going to take us through that content and teach us something. All right, thank you. Enjoy.
All right. Good evening, everyone. Can I get a thumbs up if you guys can hear me okay? All right, fantastic. Thanks a lot for being here. I know it has been a long day, lots of sessions, a lot of information, a lot of announcements. I'm glad you could make it. Welcome to Accelerate Your Development with latest MongoDB innovations. I'm Nishith. I'm a product manager here at MongoDB. I work with the query database team, working on query features. So I have been a developer myself, and as a developer, it's amazing to build something, release it out to the world, and it achieves overnight success, right? Today, we'll walk you through a journey of how a simple application grows and achieves overnight success. The panic, the stress, the investigation, and the detective work you have to do while something like this scales. And along the way, we'll learn about some of the latest and greatest innovations with MongoDB. Just a standard safe harbor statement, any forward-looking statements about our product capabilities and timing are, as always, subject to change. All right, so before we get started, feel free to scan this QR code. It is a public GitHub repo. All the codes and snippets that I'll be using is available here. You can follow along in this presentation. If you want to, you can take a look at the code and play around with it after the presentation. So while you guys do that, can I get a show of hands if there's anyone in the crowd who has been using Mongo since 3.0? 3.0. All right. Anyone since 4.0? All right. 5.0 and above? All right, few. All right. So the reason I wanted to ask that question is because I want to show you one of my favorite slides from MongoDB, right? And I know there's a lot going on here, a lot of information, but that's the point. It's meant to show you the sheer amount of innovations and features we have released with MongoDB, right, over the past decade. From a simple document database, we've went from releasing transaction support, features like time series, search, vector search, streaming, and so much more. We're innovating rapidly, and it's a testament of how broad and deep our investments have been and continues to be. All right, so let's look at some of the latest innovations that are coming up with MongoDB. With the latest version, we have really focused on the fundamentals: performance, operational resilience, security, and so much more. First, from a performance perspective, this has been a spectacular release across the board. We've made drastic improvements across all kinds of benchmarks, and we'll see more about that later, internal as well as external. For operational resilience, we have released a suite of powerful controls like server-side timeouts, persistent query settings, query insights, and so much more. It's meant for you to handle your workload spikes very gracefully. On the security side, we have added range query support for our one-of-a-kind queryable encryption. Overall, this is a very powerful release with improvements across the board in all kinds of dimensions. So let's talk about some of the new things that are coming up with 8.2 that you might have heard in the keynote as well. First, hybrid search. Full-text search allows you to get exact and precise information retrieval. Vector search is very efficient when you're trying to get a semantic understanding of your data. But in real world, you need both. With hybrid search, we allow you to combine the powerful capabilities coming up with full-text search as well as vector search within MongoDB. With 8.2, we've released two aggregation stages: $score fusion and $rank fusion, both of which allow you to execute hybrid search within your aggregation pipeline. Search and vector search are now available on community and enterprise servers. What this means is that it empowers developers to develop and deploy their AI workloads wherever it fits their needs. For example, you might be a developer trying to deploy it, prototype a workload locally, or you might want to deploy it on your own hardware. All kinds of powerful capabilities are now available across any kind of environment that you want to deploy in. Third, we have added extended support for queryable encryption with prefix, suffix, and substring support. Now you're able to execute very expressive queries on top of fully encrypted data. On the release front, we've made some meaningful changes as well. First, we have extended our long-term version release support from 5 years to 3 years to 5 years compliance. Sorry. What this means is that as a developer, you can stay on the version that you like and feel stable in for a longer period of time. You don't have to go through overhead of upgrading to a new version very frequently. And the second one, pretty prominent as well, 8.2, the minor version, is now available on Atlas, Enterprise, and Community customers for the first time. What this means is that you'll be able to access innovations we deliver and adopt them as soon as they're ready. Altogether, latest MongoDB 8 is full of exciting features and innovations. And like I said before, you're overloaded with information. So the goal of this presentation is to show you how some of these features might actually look like in practice. So I'll try to show you some of the developer experience with some of these features. So let's put them to work. Today we'll try to build a very simple app, smart home application. You guys all have sensors in your houses with EV chargers, lighting, fridge, washer, and so on. And they generate a lot of data. So our goal today is just collect this data, use MongoDB infrastructure, store them in MongoDB collections, and be able to get insight out of it. So let's dive in and see how we can solve them. For any requirements, let's figure out the requirements for this application, right? So first, I want to ingest the sensor data. So I'll be collecting the sensor data and keeping it in MongoDB collections. Second, I have an MVP feature. That means that I want to just be able to visualize and analyze this data so that I can get some sort of insight out of it. Third, I want this infrastructure and feature to be available for everyone so that people can use it. That's pretty much all. So let's map out these requirements and see what I need, right? First, user data. This includes all your PII information and administrative information about our users. So user ID, name, email, location, birthday, and so on. So we'll store this in regular collections. Then we have sensor data, right? These are time-stamped. The metrics are changing over time. We're tracking, for example, pressure, electricity usage, and so on. These are pretty good fit for time series collections, right? So let's talk a bit more about time series collections. Time series collections are a native functionality with MongoDB. It allows you to efficiently store and query timestamp data natively within MongoDB. With other data stores, you might have to bolt on and sort of like integrate and ETL your data into time series specific vendors. But with MongoDB, all you really have to do is just use this create collection command, and you have a very powerful capability within MongoDB. It has columnar compression because we fork the data into columnar format and apply very advanced compression algorithms. And it's built for modern workloads, right? IoT, financial data, performance monitoring, and so on. And one recent addition that I'm very excited about with 8.0 is block processing. The way time series collections has been designed and architected, we try to co-locate the data together, right? So if you're getting data from sensors within the same time range, we store them in contiguous blocks. So what we realized that instead of processing one document at a time in time series collections, we can actually process a block of data at a time. So when this happens in your query engine, we're actually skipping a lot of expensive unpack operations or costly memory allocation. And when we do it at scale, when you have a large amount of data, the economy of scale kicks in, right? Like your queries get super fast. And with time series collections, the impact has been that we have seen almost 20x improvement in large scale aggregations, especially with dollar group queries. And you might have already heard Accenture, they recently had a talk as well. They developed their telematics platform solely on MongoDB time series collections. So let me show you how this can actually work, right? So the starter code has this script. I execute insert sensor data.py. What this does is just insert the sensor as well as user data into my two MongoDB collections. So my data has been inserted. Then I quickly check if my data has been inserted. So I run some find command. I see that my data has been inserted. Pretty simple. And then I leverage block processing in our aggregation pipeline to visualize this data, right? And I immediately see some value out of it, right? I'm able to see some patterns about how my energy consumption looks like. I can see that at 7 a.m. every morning, my energy consumption spikes. I realize that I'm using my space heater at 7 a.m., right? So I think it's a valuable feature to have. So I do what any developer would do. I think this has the ability to go viral. So I package it up, add some APIs, and I publish it on Hacker News. And let's just assume that it goes viral, right? Huge traffic surge, a lot of people are signing up. Infrastructure is training, right? A lot of servers and database are now handling much higher load People are inserting a lot of their own data, they're querying this data, and so on. It's a great problem to have, but more users mean more problems, right? I'm stressed. Even a small mistake can impact almost all my users. And we have critical performance bottlenecks going on, right? And I don't know what is actually happening. It's chaos, right? And in these kind of situations, I need a directional guidance of what is actually happening. And that's where Query Insights come in. Query Insights is a new tab on Atlas, and it's almost like a monitoring tool for all your database operations. It helps you get a directional idea of what exactly is happening in your cluster or your deployment. So you can see what kind of queries are running slow, you can pinpoint exactly what is going wrong, get more granular details, and gain enhanced visibility into your deployment. So I'll try to simulate this, right? So I run this overload.py script, and I hammer my database with unoptimized queries and unindexed queries, right? So what that does is that it instantly spikes up my CPU from stable 7% to 100%, over 90%, right? If your system resources are approaching almost full capacity, that means that your rest of your database operations might be affected. So left unchecked, it could bring down a whole cluster or your deployment. I need to contain this. So what do? First, I need a direction of what's actually going wrong, right? So I go to my query shape insights, and I immediately see a time series graph of my query, right? And I zoom in on the time window when I executed this query, and I can immediately see where it went wrong and how long it was running. Then Query Insights also allows you to give you more granular insight into almost all your queries in different dimensions, right? So for example, you can sort it by total execution time, you can sort it by execution count, average execution time, and so on. So here I've highlighted my query in red. I can see the structure of my query as well. So now, and you can get more granular information about your query, right? So for example, in this query, I see that total keys examined is 0. That means my query was not leveraging any index at all. So in these situations, you need to contain this chaos immediately, right? You don't have the ability to, for example, push a hotfix or immediately fix these things, right? You need to stop this bleeding as soon as possible. And that's where things like operation rejection filters come in. It's like your emergency lever for when things are going wrong. So let's see how we can do that. First, I need to identify my query. What query is actually going wrong? So I go onto my query insights, I figure out which query is running slow, so right here, and I try to identify the query shape hash. And you can get this from your slow query logs or Atlas, just like I've shown here. So there you go. Parse log, and I copy my query shape hash. And query shape hash is a unique identifier for your query, right? I'll copy this hash, and I use the admin command, and I paste my query shape hash into the set query settings. This is exactly what persistent query settings looks like. And I set reject to true. What this does is that every time your database is being hit with this particular query, it immediately rejects it. That means your system resources are being protected, and you have stopped the bleeding immediately. I did that, and now, as I can see, my cluster usage has dropped from 100% to 6% right there, because all those problematic queries are now being blocked. CPU utilization has leveled out, and I can take a breath. So putting it all together, first, I was able to leverage my real-time metrics to figure out something is wrong. Then I used Query Insights to get a directional idea of what might be going wrong, right? What queries are actually running slow or are problematic. Then I used operation rejection filters to reject the query that was impacting my database. And then I can start investigating, getting the root cause, right? And all of this, from spotting the problematic query all the way to stopping the bleeding, took me almost about 3 minutes. That's the power of the overall operation resilience features that we've released. I gained visibility, control, without pushing any application changes or deploying any hotfix. So I contained the fire, and I know that I'm sitting on a lot of valuable data. So how do I take this from side project to viable business? How do I improve my security and maintain user trust? That's where things like queryable encryption comes in, right? It's a very powerful capability. It allows you to encrypt your data end to end, at rest, at motion, and while processing your query as well. For example, in my use case, I might want to query my data on social security number, for example, right? So I can run range queries from, for example, 123 to 999, and that remains fully encrypted. That means your data is not visible to anyone. My app now simply can pass all the compliance and legal requirements just because the encryption is so strong. And with 8.2, we released prefix, suffix, and substring support. So for example, if I'm looking for people whose first name starts with so, I can use queryable encryption to do so. If I want to find people with the last name Morrison, I can do that as well. Or for example, my data has, for example, refund, electricity refund. You can run that exact substring search in a fully encrypted data to secure your user information. So now, I've contained the fire, I have added security, and now a lot of people are using my application, right? I'm getting users from Germany, Japan, UK, it's going global. So the next challenge is, how do I scale this, right? And I want to show you how simple it is to scale an application like this as a single developer. As a refresher, in MongoDB, there are two ways to scale. You can either do vertical scaling, so that means you're going to deploy a beefier cluster, a bigger cluster, or you can horizontally scale. That means you're going to spin up new computers so that you can distribute the load. And let me show you how easy it is to do so, right? And all of this is happening in Atlas UI with ClickOps and just using Mongo Shell. I go to the Atlas UI, and in few clicks, I've added a few shards to my cluster. And now, my application can scale limitless. Freedom, flexibility, and global scale. MongoDB provides you consistent developer experience no matter where you deploy your application. I might be running it on my laptop, on data centers, on-prem, or on the cloud. It gives you consistent experience everywhere. Avoid vendor lock-in, right? You can deploy individual clusters into different cloud providers. But more interestingly, it is truly hybrid experience, right? So for example, it's not just that you can deploy individual clusters in individual cloud providers, even a single cluster can be deployed across different cloud providers. For example, you might have a cluster deployed with multiple shards. You can have one shard in Azure and one shard in GCP, right? That's a capability only MongoDB can provide. You can truly avoid the vendor lock-in. So now a word on performance. That helps you no matter what. This is what truly drives more database usage per dollar. And we have made drastic improvements in performance with our latest release. So, like I said, we've made major improvements across all industry benchmark, and we talked a lot about this in the keynote as well. So I'll quickly recap: YCSB, TSBS, link bench, and so on. As you can see, compared to 7.0, 8.0 has made drastic improvements in multiple dimensions. Read queries, read and update, bulk inserts, time series queries have all achieved 2 to 3-digit improvement across the board. And that's not all. With 8.2, we've made even more further performance improvements. Faster on indexed query performance, faster in memory reads, array traversal, time series insert throughput. Now, let's recap what I did, right? What are the key MongoDB innovations that I used? Time series collections with block processing, query insights and query settings, queryable encryption to secure my data, sharding enhancements to scale, and multi-cloud and multi-region support to go truly global, and performance giving us more database usage per dollar, again. Altogether, 8.0, again, was a standout release, and we have a lot of exciting announcements coming with it. So put together your upgrade plan, and I hope you use it. Now I'd like to welcome Bruce Sandel from Google, and we will be talking about how customers can use MongoDB and Google Cloud together.
Thanks, Ashish.
All right.
Great job. So hi, everybody. I'm Bruce Sandel from Google Cloud. I'm a solutions architect on the partner engineering team. And the team that I work on is focused on database and data analytics partners. So we work closely with MongoDB. I came to Google as part of the Looker acquisition. So I've been working with MongoDB for many years before I came to Google. And if you do use the Looker integration for MongoDB, I wrote that.
Awesome. All right, so to start off, can you tell us a bit more about Google Cloud and how customers can use MongoDB and Google Cloud together?
Sure. So Google Cloud MongoDB is deeply integrated into Google Cloud. If you've seen Google Cloud or MongoDB in the Google Cloud platform, it looks almost like any other first-party Google Cloud service. To use it, you can subscribe from the marketplace, which is going to burn down your Google Cloud commit. You get billed through Google, so just one bill. And you can use GCP Cloud Monitoring for viewing logs and metrics and creating alerts. It's running on the same global scale infrastructure that powers the rest of Google Cloud's infrastructure, and you can, the partnership has been so good that for the last 3 years, MongoDB has been a Marketplace Partner of the Year.
Awesome. Can you tell us a bit more about the most common use cases of how MongoDB and GCP comes together?
Sure. So one of the most common use cases we have is replicating data from MongoDB to BigQuery for doing advanced analytics. So you can do like your real-time reporting on your transactional data within MongoDB, but if you want to combine that data with the data that's already in your BigQuery data warehouse so that you can get a complete view of your data landscape, you can do that by replicating the data to BigQuery. And there's a few ways to accomplish that. The first is that you can use Dataflow, and we have pre-built templates for Dataflow, so you can do that either via batch or streaming. There's Data Stream that you can use, which is a fully managed service. And then you can also use PubSub with change log or change streams for near real-time inserts into BigQuery. If you're a data scientist, you can use a Python notebook, and within the Python notebook, you can use the PyMongo Arrow library, and you can also use the Big Streams or BigQuery Big Frames library to pull data in from both MongoDB and from BigQuery, combine that, work with it, send it off to Vertex AI for doing your AI and machine learning requirements. And then if you want to take that data, recombine it with some of the data that's in MongoDB, we have templates for Dataflow to bring that data back into MongoDB so that you can like have your predictive analytics data right beside your transactional data. MongoDB can also be used as a vector database for building your AI applications. And if you are an AI-based startup, we also have a great joint startups program where you can get resources and credits.
All right, fantastic. So you mentioned AI and Google Cloud. I've read that Google Cloud is used by almost like 90% of the unicorns out there. Could you tell us a bit more about why Google Cloud is so popular amongst these like big enterprises trying to leverage AI?
Sure, I think there's a few reasons. And the first is really that Google just has a long history with AI research and innovation, and they've been driving forward AI research for decades. So if you're familiar with Google Translate, which I'm sure everybody is, that's been around for 20 years now. For younger people in the crowd that may not remember AlphaGo, that happened about 10 years ago, and that was an AI model that was built to beat the world's best Go players, which at the time people thought couldn't be done because Go is a two-person game like chess, but it's much more complicated computationally than chess because the board is much bigger, and in chess there's about 35 possible moves in each turn. In Go there's about 250 possible moves in each turn. So for years they've been trying to beat the world's best Go players and failed. But AlphaGo was able to do this using a bunch of new neural network techniques. And it was a big enough deal that 2 million people watched online to see it happen, which is a small number now, but at that time, that was a lot of people. So this is just a few examples, but all of this just sort of out of necessity led to the creation of sort of a full-featured platform that supports the development, deployment, and maintenance of AI applications. So, if you're building an AI application, building the POC is a lot of fun. You can show your coworkers all the cool things you did and what you can do with it. But getting that from POC to production is really hard, and it's the reason that a lot of implementations fail for AI projects. So this platform makes it a lot easier for you to get the data, your projects, from POC into production. It's a single open platform, and in almost all levels of the platform, you have your choice between Google first-party products or others. So you have a choice between Google TPUs or using NVIDIA GPUs. In our Vertex AI platform, which is a platform for building your AI applications, we have our model garden, which allows you to choose from over 200 models, which includes Google first-party models, partner models from third-party companies, as well as open source models. And so with Vertex AI, you can build your AI applications with your choice of no-code, low-code, or full-code utilities. And all of it is running securely on Google's planet-scale infrastructure.
Amazing, a lot of things. So I personally try to keep up with all of these AI advancements, but it's so hard to keep up because the space is evolving so rapidly.
Definitely.
I'm curious, since you're close to the space, what are some of the exciting innovations that you're excited about yourself from Google?
So there's been a lot of advancements, just recently, and so back to the deployment and running of these AI tools. The more advanced when there's more advanced features, that creates more problems for securing and scaling and deploying these things. And so, maybe not exciting, but there's been a lot of advancements in ML ops so that you spend a lot less time worrying about how to secure these things, deploy these things, keep them up and running. So a lot less time on infrastructure and plumbing so that you can spend more time on the fun part of building these things. So I'm really excited about the recent Gemini 2.5 release. It provides a lot of advanced reasoning capabilities that allow the model to go far beyond the classification and prediction that models were good at in the past. So they can draw logical conclusions that include context and inference. You may have heard of the Gemini 2.5 Flash image, which is also known as Nano Banana, which makes it really easy to just use natural language to create images. You can combine images, like you can take a picture of a person and a picture of a location and ask for a combined image of that person in that location. So lots of really cool things that you can do with that. We also released our new VO3 for making short video content. And this is studio quality content that you can add music, sound effects, and audio to. And you can use this whole suite of products together. So you could use a Gemini model and ask Gemini to generate a prompt for you to use in Nano Banana to produce just the image that you're interested in. Then you can take that image, add it to VO3, and ask VO to animate that so that you can kind of build your whole project as based on the tools that you have available. And if you've seen any of the things that people have done with the new VO3, it's pretty amazing. The Nano Banana release has been out for just a few weeks, and in the first 2 weeks alone, we had over 500 million, 500 million people that created and edited images with that new model.
Sweet. So can you tell us a bit more about how, for example, customers can use Google and MongoDB together to build AI applications? We talked a lot about Google, but what is out there? How can people leverage MongoDB as well as Google Cloud both?
Yeah, for sure. So one of the areas that we've had a lot of success is with RAG architecture that includes MongoDB and Vertex AI to deliver some really impactful solutions. So for those of you that might not be familiar with RAG, what RAG is, it stands for Retrieval Augmented Generation, and it allows you to augment the general knowledge of an LLM with some very domain-specific knowledge.
All right.
Oh, there's some more, sorry.
Oh, I think.
That's okay.
All right, so RAG architecture, we talked a little bit about it. Now we have also seen a lot of trend around like agentic frameworks. If you could talk a little bit about how Google is doing or introducing new agentic capabilities in general.
Sure. So the Vertex AI platform has introduced a lot of new tools for building, managing, supporting, all the way through the agentic AI lifecycle. So it starts with the AI Agent Builder suite of tools, which includes the Agent Development Kit. The Agent Development Kit, it supports all of the new open protocols for agent development. It's great for building single-purpose agents, but where it really shines is like building multi-agent solutions where somebody might ask an agent to do one of many things, and the agent figures out what it needs to do and which other agents it needs to interact with in order to satisfy the user's request. So you may have heard about MCP servers. So MCP servers allow agents to interact with outside resources like databases, for instance. Google Cloud has the MCP database toolbox that you can add to your agents. That's a really easy way for you to get data from databases. And it's not just Google databases that it supports a number of third-party databases as well. And then I don't know if you've heard of the agent-to-agent protocol, but the agent-to-agent protocol can also be used for communication between agents so that they can discover each other, learn about what each other's capabilities are, how they should interact with each other, and they can actually build multi-step workflows between each other. The Agent Engine Garden has all kinds of different tools and utilities that you can use as a starting point for your own agent development. So you don't have to build everything from scratch. There's tools that you can use already, and tools is just a generic term for things that an agent has the ability to do. So it could be something that operates inside the agent, like running a Python command to get the current date and time, or it could be going out to a third-party API to pull in some data. And then the Agent Engine allows you to deploy, manage, and monitor these agents on a number of different deployment frameworks.
All right. So I know we were talking about the open source agent payment protocol that Google recently announced.
Yeah.
Can you talk a little bit more about that? Like how how can these agentic frameworks can actually be leveraged by users?
Yeah, so there's a couple of new features that I'd like to talk about. So the first is the AI Memory Bank, which was just announced a few days ago. And both of these new features are a result of people that have been using our agent building tools and said, these are great and I've built really incredible things, but I think I ought to be able to do these other things as well. So one of those things, which is really important, is being able to maintain context across sessions. So you probably already know that you can work with like a chat bot, and it's got what's called multi-turn. It remembers what you've been talking about, so you don't have to repeat your question. So you can say, build me a pie chart that shows all these things, and then you can say, convert it to a line chart. So you don't have to rephrase all the things that you've just said. And that's great within a session. But let's say that you are asking an agent to find you a shirt that matches a hat that you just bought. And you tell it what size shirt you want. With Memory Bank, it's going to remember what size shirt that is that you want. So the next time that you go and ask and say, hey, I need a shirt with this logo on it, you don't have to tell it what size you wear. It's going to already know based on the data that's in the Memory Bank. And Memory Bank is smart enough to actually update that information as well. So, if you put on a little weight and you needed an extra large instead of a large, you can tell it you need an extra large shirt, and it's going to update that data in Memory Bank that knows about what size you wear. So that's one really cool feature. And then just yesterday, we announced a preview of the A2P protocol, which is the open source agent payment processing protocol. So right now, online payment infrastructure assumes that you as the human are going to be making the purchase. So you're going to click a button that says buy, you're going to put in credit card information. But what if you want to turn an agent loose to do that sort of purchasing for you? Like you heard a rumor that your favorite artist is going to be performing at the Sphere in the next few months. So you put an agent to work and you say, as soon as tickets go on sale for this concert, I want you to buy me the best tickets available. And so in order to do that, it needs to be able to purchase on your behalf, which is kind of a scary thing to do. So this new A2P protocol, we have over 60 partners that have worked with us on the development of this. So like PayPal, Visa, American Express, so people that care a lot about secure payments. And so that was just released yesterday as a preview, and there's also an extension for it that supports purchases made with cryptocurrency.
So there's a future where I can just spin up an agent and it goes out there, does the purchase for me, completely secure and handled by the agent itself.
Absolutely. So if you have a regular grocery list, you can just have your agent take care of ordering that, paying for it, and it'll just show up at your door when you're ready for it.
All right, awesome. Can we talk a little bit more about some of the joint customer stories that we have with Google Cloud and MongoDB?
Sure. So one of my favorite success stories is Bright AI, which we built together with UKG. So UKG runs a lot of, especially their AI-related work on MongoDB. And so the reason I really like this example is, first of all, is just the sheer scale of it. So if you're not familiar with UKG, they're one of the world's largest providers of human capital management software. So just employee software. And so they have over 14,000 employees and 80,000 organizations use it worldwide. So just the scale of people that are using this is pretty huge. And second is really how many of our AI features that it takes advantage of. So it uses connected agents and generative AI to create a trusted advisor that the employees can use for handling all kinds of like routine tasks, like generating job descriptions. It offers conversational reporting, so users can just ask it for what they want. It knows what the data sources are that it needs to get that data from and just returns the data. So it takes away a lot of complexity, a lot of barriers to entry, a lot of relying on people that are well versed in the data to produce reports for you. So you get access to a lot of data that maybe you wouldn't ordinarily know how to get or have access to. You can use it as a self-service tool for employees for doing things like accessing their payroll information, accessing their vacation information. So lots of cool things that you can do with it.
Amazing. All right, awesome. I think we'll see more of these use cases and customer stories in the future with the joint partnership as well. That's all the time we had. It was great learning about Google. I hope you learned quite a bit about the database improvements as well. Thank you all for listening in. We will be right here, Bruce and I, so if you have any questions, feel free to come up and we'll try our best to answer it. Again, thanks a lot. I know it has been a long day, but I hope you enjoy the session and the day itself. And yeah, that's all.
Thanks for sticking around, everyone.